So, Sanbonani Abafundi, welcome back. Today we start our study of trigonometry, and while most of the trigonometry that we're going to go over is actually a revision of stuff that you should know from grade 10 and 11, there is some new stuff as well. So what we're going to do is we're going to go sort of right back to the beginning, and that's a big advantage for those of you who don't fully understand it yet. And I say yet because we know that you are going to soon. So let's dive straight in, and let's just remind ourselves how kind of trigonometry actually works. Okay, so what we've got here is we've got a little simulation where we can measure angles, and remember that in maths we measure angles going from sort of 3 o'clock, okay, on the clock face, or east, and we go anti-clockwise. All right. In geography, we actually start at 12 o'clock and we go clockwise. Right, but not in maths. Right, so that angle there, for example, about 50 degrees. Every angle has got three values attached to it. It's got an x value, which is the x value of that point, a y value, and an r value. R is the length of the radius, okay? And we can create some different ratios, and the ones that we need to know for high school maths are sine, which is the y value over the r value, cos, which is the y value over the x value, and tan, which is the y value of the x value. So for example, we can calculate, if sine would be the y value, all right, 6,13 over the r value. It would be 6,13 over 8. The radius here is 8. Okay, and we get a number of about 0.77. Just to show you that that's actually exactly what our calculator would give us if we asked for the sine of 50. Sine of 50. I'm hoping you can see enough of the calculator. Yes, you can. All right, and there it is. It's 0.766. It rounds up to 0.77. Okay, now a really important idea is that it actually doesn't matter how big the circle is. So watch what happens if I make the circle bigger. You'll see the x and y and r values are all getting bigger. Now the radius is 10, but the sine of 50 is still exactly the same size. So the sine of the angle is not dependent on how big the circle is. All right, we can make the circle a radius 5. All right, notice that if I want you to watch what happens, and the easy one to watch would be cos of 50. If I make the radius twice as big, I make it to 10, that 3,21 actually changes to 6,42. Okay, or 6,43. That's just a rounding thing. But basically, an accuracy in terms of what the computer is showing. Basically, the ratio size doesn't change as we grow the size of the circle. So let's make it a little bit smaller just so that we can, let's try and see if we can get it back to exactly 8. And I don't know if my hand will be steady enough to do that. Okay, it looks like we're going to maybe just go to, yeah, let's try and go to 8. Okay, let's try and go to 5 then. We'll go exactly to 5. Okay, what I want to show you now, which I think is fairly obvious, is that as we move this angle around, in the second quadrant, some of our ratios become negative. In fact, cos and tan become negative. And the reason cos and tan become negative is cos is the x value, and notice now the x value at this point is negative, divided by the r value. The r is always positive. Sine is y over r, so it's still positive in what we call the second quadrant. Cos will be negative, and so will tan be negative. Tan is y divided by x. Right, if we go into the third quadrant, the only ratio that's positive is in fact tan, and the reason tan's positive is because both x and y are negative, and when we divide a negative by a negative, we get a positive. And likewise, in the fourth quadrant, the only ratio that will be positive, in fact, will be cos, because now our x value is positive and our y value is negative. Okay, we will come back to this little trig board in the future, but for now, that's all we want to just quickly show you. Okay, so this really is a bit of a summary of what we've told you there. Okay, and the idea that for any angle, we've got an r, an x, and a y value. Right now, right tonight, we want you to learn these definitions. If you don't know them yet, learn them. Learn them off by heart, backwards, forwards, upside down. Okay, right. And now we remind ourselves of this thing which is called the cast diagram. These are the quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4, okay? And remember, r is a length, it's always positive. And these are the signs of x and y in the different quadrants. In quadrant 1, both x and y are positive. In quadrant 2, x is negative and y is positive. In quadrant 3, they're both negative. And in quadrant 4, x is positive and y is negative. All the trig ratios are positive in quadrant 1 because they involve dividing 2 of any 3 possible positive values. In quadrant 2, the only one that's positive is sine. Cos and tan are negative. In quadrant 3, tan is positive and cos and sine are negative. And in quadrant 4, cos is positive and sine and tan are negative. Okay, this little diagram, which teachers often call the CAST diagram, C-A-S-T, right, is very helpful in terms of reminding us what's positive where, okay? It's not a very useful name, in fact, because this is quadrant 1, we actually start there. So actually a little rhyme which starts with A-S-T-C is maybe better, okay? All students take coffee, all right? Or all students take chocolate, okay? Just remember that diagram. Okay, and when you get into a test or exam, you might want to just write it down like that. All, sine, tan, cos. Okay, now we're going to ask you to pause the video and we're going to ask you to just tell us whether these numbers are positive or negative, these trig ratios, all right? Now we're going to think about which quadrant we're in. Something that we didn't say is that if we go in a clockwise direction rather than an anti-clockwise direction, then we go the other way. So for example, this angle here is negative 27 degrees. Negative 27 degrees is actually in quadrant 4. Okay, right. Let's have a look now. So pause the video and just tell us the signs of each of these ratios. Okay, just question 1. Okay, the first one, tan of 123, we're in that quadrant, and tan is negative. Okay, sine of 300, we're in quadrant 4, and sine is negative. Cos of negative 56, we're actually in quadrant 4, right, because we're going 56 degrees clockwise instead of anti-clockwise, and cos of negative 56 would be positive. Tan of 170, we're in quadrant 2, and tan is negative. Cos of 234 is actually in quadrant 3, cos will be negative. Sine of 120, we're in quadrant 2, positive. Cos of 200, we're in quadrant 3, negative. And tan of 181, we're in quadrant 3, and tan is positive in quadrant 3. Okay, we're hoping that you were able to do those quickly and easily. Now, we're going to refer back quite often to a result from what we say is page 2, but it's actually page 2 of our trigonometry. Let's just see what that result says. What that result says is that if we are anywhere and we add 360 degrees, a full rotation, we get back to exactly the same place. All right? If we're at 27 and we add another 360 degrees, we get back to exactly the same place. Likewise, if we're at some place and we subtract 360 degrees, 360 degrees is a full rotation, okay? We get back to the same place. So now let's have a look at these questions. Because cos of minus 200, we want to think about where minus 200 is. Now, there's two ways of doing this. We could just think, okay, well, if we went negative 90, negative 180, that's negative 200. We will actually be in quadrant 2. But another way of thinking of this, we can, without changing anything, we can add 360. So if we add 360 here, all right, then we're going to get cos of 360 minus 200 plus 360, we're going to get cos of 160. And cos of 160 is easier, I think, to work out that it's in quadrant 2 than by going the other way around. Okay, is cos of 160 positive or negative? It is definitely negative because we're in quadrant 2. Okay, tan 3,695. Now, what we're going to do here, we're going to write this 3,695. That's an enormous number. What we're going to do is we're going to take 3,695 and we are going to take off 10 rotations. Now 10 rotations, one rotation is 360 degrees, so 10 rotations is going to be 3,600 degrees. This number is easy to get in our heads, it's just 95. Which quadrant are we in if we find the tan of 95 degrees? All right, we are in quadrant 2. Well, it's not really about the tan of 95 degrees, it's just we're in quadrant 2. Okay, and so now if we were to think about tan in quadrant 2, definitely negative. Okay, right. What about cos of negative 380? Okay, let's add 720 degrees. Now 720 degrees is actually 2 lots of 360. So this will be the same as cos of minus 380 plus 720. Right, and what that's going to be, it's going to be cos of 340 degrees. So 340 degrees. Which quadrant are we in at 340 degrees? We're in quadrant number 4. Is cos positive or negative in quadrant 4? Well, cos is, sorry, not there at all, down there. Cos is positive. There's our final answer. Okay, and the last one, tan of 500. Okay, we can subtract 360. If we subtract 360 from 500, we will be in exactly the same place. So tan of 500 is actually exactly the same as tan of 140. Which quadrant are we in at 140 degrees? Well, we're in quadrant 2. And is tan positive or negative in quadrant 2? It's negative. And there's our final answer there. Okay. Right. So we're going to stop that lesson there. All right. A reasonably short lesson. Spend the rest of the time, if you need to, learning your trig ratios, because in the next quadrant, in the next lesson rather, we're going to do these questions. Okay. And we're going to work out some missing information. So we will dive straight into that next time.